All right, welcome back to Steve's Solar Garage. Last week we tested that new shade stopper panel, and this week we're going to make the test a little more fair, because if we look at the panels over here, you'll see that they're all leaning against the garage, and as the sun goes over and casts a shadow, it tends to kind of give this one a slight unfair advantage. So what we want to do is move all of this stuff out of the way and actually build a wooden solar panel frame here that we can put these panels on. So we're gonna clean this up, build the frame, and then we're gonna put a selection of solar panels on here, hook them up through the garage, and we will run another test for a week and see how they perform. That's the plan.
And you think the idea is to build with that wood over there?
Yep. Let's just see what we can put together. Maybe we'll angle them up a little more. Maybe give them a 45-degree angle.
Whatever you think works.
All right, let's give it a shot.
All right, let's do it.
Do this guy here, goes to this guy here, and then we need the bottom piece right here, right? That's it, right there?
I think, yeah.
Awesome, bitch. Just trying to get good on the problem.
Oh, is it up a nail in there?
Yeah, where's that hammer?
Oh, it's right up here. Right above the camera.
Yep, we need the camera. Caleb Hammer! YouTube shout out to my favorite YouTube channel.
Ready?
You're not gonna pull it out? Oh, it works too. Alright.
This hasn't got to be perfect.
Oh! The shade stopper! And the Renogy!
Hey, perfect.
Stick that little cable up.
Let's have the back. Okay, so this is another shade tolerant panel. This is an Optivolt. It's a 100-watt panel, just like the shade stopper. There's not a lot of reviews on this online, but this apparently has some kind of special technology where I think it's doing more than just using bypass diodes on the cells. So it'll be interesting to see how this does. We will do some individual tests on each of these panels at some point. But yeah, so this thing actually outputs at 48 volts, and so we have a grid tie inverter that can handle that. Okay, ready?
Yep.
It's pretty light.
Very light.
Yeah, it's not bad. So the back connection is actually not a standard solar panel connection. It has like an adapter.
You're gonna have to change it out or something?
Yeah, it has like a little cord that converts it to MC4. That's pretty nice. Is this gonna fit? Oh,
To the left more. Yeah, you gotta watch out that bracket.
yeah. Don't want to break anything. Oh my god, look at that. That's crazy. The order in which we have this set up, we're going to start with panel. Ooh, there's a fly. This is the panel we started with, the shade stopper panel. That's with the bypass diodes on every cell. And I want to take note of the physical size of the cells. They're kind of half cells. This is 100 watts. This is the Renogy panel. Again, no kind of special shade technology. Similar size cell. Similar size overall panel.
True.
This is the Optivolt. And no, if you take these cells, it would only add up to like 18 volts, but this is outputting at 48 volts. So there's something special about this. And this is supposed to be shade tolerant. And then this is old school 175 watt panel. And you can tell that the cells, if you compare the Optivolt cells to these cells, these are about twice as big, which makes sense given it's twice the power. So it'll be interesting to see, well, I'm interested to see how this one does in shade, because it has bigger cells. And a part of the problem is kind of holding the voltage up while you're trying to pull power from it. So we're going to test these panels over the next week. We've got panel 1, 175 watts, panel 2, 100 watts with shade tolerance, panel 3, just a standard 100 watt of energy, and panel 4, the shade stopper, which has the individual bypass diodes on each cell. Test it for a week, collect the data, and we will see how it does in, hopefully we'll be able to catch like some shady weather, some raining weather, just kind of different environments. We'll write that down as we go. And let's see, I think what we're looking for is to see, one, how much overall energy they produce, but also how do they perform on days that really aren't ideal for solar. I think that's the big question. And then in the future, we'll test these in actual scenarios where something is actually casting a shadow on them, which I'm assuming the shade tolerant panels will shine when that happens. Anyways, I think that's it.